everyone, so today we're going to learn about distance in the coordinate plane. You're going to need a spiral, a pencil, a calculator, and the grid paper that I gave you in class. So why are we learning about this? Well, map makers use a coordinate grid system for math. The coordinate plane is another type of grid system. A coordinate plane is a grid formed by the intersection of two number lines. You can use a coordinate plane to locate and name points. So let's review. A coordinate plane is a grid formed by the intersection of two number lines. You can use a coordinate plane to locate and name points. We already wrote that down from the other slide. You don't have to write it again. So here we have the coordinate plane. We have our x-axis, which is a horizontal line, and our y-axis, which is the vertical line. The axes are divided into 4 quadrants. We always name our quadrants with Roman numerals. So this is quadrant 1, quadrant 2, quadrant 3, quadrant 4. It goes counterclockwise. The origin is where both of the axes intersect, and that point is 0, 0. Anytime we are looking at the coordinate plane, you want to make sure that you label the quadrant by Roman numerals. This quadrant would be a positive x and a positive y. This quadrant would be a negative x and a positive y. This would be a negative x and a negative y. And this is a positive x and a negative y. And we're going to talk about how we can plot these points. So an ordered pair, x and y, gives the coordinates of the location of a point. In the graph above or on the page before, A is at 2, negative 4. You always start at 0, 0, read left to right first, so it goes to the right, which is a positive 2, and then down 4, so negative 4. So you'd write 2, negative 4. The x-coordinate tells the number of horizontal units. The y-coordinate tells the vertical. You can graph a point when you know its coordinates, and you can also use the Pythagorean theorem to find distances in the coordinate plane. Let's practice writing the ordered pair for the following points, A, B, C, D, and E. So if we were to write an ordered pair for A, we would go from the origin, it went to the right, 1, 2, so the x value would be 2, and then up, 1, 2. So the y value would be 2. You want to make sure you write it in parentheses. So now I want you to practice writing the ordered pair for B, C, D, and E. Be careful with B and E. We might not move any left and right, but we go up and down. Here, we might not move up and down, but we did go right. You should have gotten the following answers. B is at 0, negative 4. We didn't move any left and right, so we're at 0, but then we went down 4, so negative 4. C, we went to the left, 3, and up 7, so a negative 3, positive 7. D, we went to the left, 7, which is a negative, and down 2, which is a negative. And E, we went to the right, 9, which is positive, and we didn't go up or down any. So now we're going to practice using what we know about the coordinate planes and how to plot to find the distance on the coordinate plane. So let's first plot points C and D, and notice we always plot in capital letters. So C is at 2, 2, so I'm going 1, 2, up 1, 2, put a point C, and D is at 6, 5. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5. We're going to draw a line between C and point D. So now what we want to do is we connected our points C and D. So notice you can draw a right triangle by drawing a vertical segment down from D and a horizontal segment from C. And they're going to intersect at point 62. So we have 1, 2, 3, 4, 5, 6, up 1, 2. So this forms a right triangle. We wanted to see where we can draw a vertical line and a horizontal line and where they will intersect. So now, in order to figure out what the horizontal leg is, we want to take our x values and subtract them. So I'm going to take 6 minus 2, and I'm going to get 5. Then to find our vertical leg, I'm going to subtract my y's. So 5 minus 2, which is 3. Again, my horizontal leg, I took 6 minus 2 to get 5. For my vertical leg, I subtracted the y's, 5 minus 2 to get 3. So now I know this should be 4. 6 minus 2. Sorry about that. So we got 4. So this length is 3, and then this length is 4, this length is 3. So now we have enough information so we can use the Pythagorean theorem that we've been learning about. A squared plus b squared equals c squared. So I know what the length of my legs are, 4 squared plus 3 squared, and I'm looking for c squared, the hypotenuse, the side that's across from the right angle. So I get 16 plus 9 equals c squared. 16 plus 9 is 25. I have to take the square root. And I know that the length between C and D is 5. So let's go back and look at what we did. We plotted the point C at 2, 2. We plotted the point D at 6, 5. I drew a vertical line and a horizontal line until they met to form a right triangle, and they met at 6, 2. Then I wanted to find the horizontal leg. So I took 6 minus 2, and then for the vertical leg, I did 5 minus 2. So x values for your horizontal, y's for your vertical. And then I used the Pythagorean theorem like we've been learning about. So let's do another one together. A is at 2, negative 3. B is at 4, 3. I connect my line. So now what I want to do So now let's try this one. A is at 2, negative 3, and B is at 4, 3. We're going to connect our line. So again, I want to form a right triangle. So I'm going to draw a vertical line, and I'm going to draw a horizontal line until they intersect. So now, like we said on this side, our horizontal is our x values, our vertical is our y values. So we want to subtract our x values first, like we did here, 6 minus 2. So I'm going to take 4 minus 2, and we get 2. Then I'm going to take 3 minus a negative 3. for dealing with integers, anytime there's two negatives, it automatically becomes a positive, so I get 6. So this value is 2, this leg is 6. Now we're going to use the Pythagorean theorem. A squared plus b squared equals c squared. So 2 squared plus 36 plus 6 squared, which will give us 36, equals c squared. So 4 plus 36 equals c squared. 36 plus 4 is 40. And we're going to take the square root, find that on your calculator, get a decimal. We're going to round to the 10, so it's 6 and 3/10. So the distance between B and A is 6 and 3/10. Go ahead and try this one on your own. So plot point A and plot point B, connect them, find your vertical, the horizontal. Again, you subtract your x for your horizontal, your y for your vertical, and then solve with the Pythagorean theorem. So let's look at how we solved this one. So I plotted point A at 2, 1. I plotted point B at 7, 9. I drew a vertical line and a horizontal line and saw that they intersect at 7, 1. I then subtracted my x values, 7 minus 2 to get my horizontal, 9 minus 1 to get my vertical. So I have 5 and 8. So I used the Pythagorean theorem, plugged in my value, got the answer of 89, took the square root and rounded to the nearest tenth. So 9 and 4/10 would be your answer. Go ahead and try this one on your own, doing the same thing. Plot the point, draw your line, form a right triangle, subtract your x values, then your y values, and see what your answer is. So when you try this one, plot A at 2, 2, B at -3, 1. Drew my vertical line, drew my horizontal line. I then did -3 minus 2 and got a -5, and 1 minus 2 to get a -1. Well, when I'm looking at distances, I'm not using negatives, so I just automatically know it's going to be +5 for this line and a -1 or a 1 for this line. We also know if we take a -10 to negatives, you're going to get a positive. So if you use the negatives, you still get 25 plus 1 to get 26. Take the square root. It was 5 and 9/100, so you round up to 5 and 1/10. Here this problem, it says the library is 5 miles north of your house. The post office is 6 miles east of your house. So it tells you that it's 5, or I can count 1, 2, 3, 4, 5, and then it's 6 miles, or I count 1, 2, 3, 4, 5, 6. So again, I can do what I was doing using the Pythagorean theorem. 5 squared plus 6 squared equals c squared to figure out the distance from the library to the post office. So go ahead and try that one. So when you finish this problem, you should have gotten 7 and 8/10. 5 squared plus 6 squared is 61. Take the square root. So let's look at this problem. It's similar to the one we just did. It says your school is 3 miles south of your house, and the park is 5 miles east of your house. To the nearest mile, how far is your house from the park? So if you want to use your grid paper and draw this, you need to label your house. We're looking at the school and the park. So it says your school is 3 miles south of your house, and the park is 5 miles east of your school. To the nearest mile, how far is your house from the park? So I want you to use this previous slide, go back if you need to. Think about how you would draw this triangle. Set that up. So if you do this picture, you notice here that the home was at the origin, so that's where I started. So it's 3 miles south, and then from here the park is 5 miles east. So go ahead and use the Pythagorean theorem to answer this question. So you should have gotten that the house, from your house to the park, it's 6 units. So let's look at our last problem. It says a softball diamond has the shape of a square. The distance from home plate to second base is about 85 feet. Find the distance a player would run from going from first base to second place. So if this is home plate, and it's saying that the distance from home plate to second place is 85 feet. This is second, this is first, this is third. It wants to know the distance that the player would run going from first base to second base. So I want you to think about what we would do to find this answer. So let's take a look at our last problem. The mall is 5 miles north of the library. The roller skating rink is 10 miles east of the library. To the nearest mile, how far is the mall from the roller skating rink? So this is going to be the mall. And it says that the mall is 5 miles north of the library. So I went down because I want the mall to be north of the library. Then it says that the roller skating rink is 10 miles east of the library. I want to know how far is the mall from the library. So again, we know that this distance is 5, this is 10. So go ahead and use the Pythagorean theorem to solve this. So you should have gotten an answer of 11 2/10. 5 squared plus 10 squared, 25 plus 100, take the square root and you get 11 2/10. I want you to make sure that you took notes, go back and listen if you need to, and write down any remaining questions that you have. When you're finished, go to the website, click on the link, and make sure you answer the question. Have a good night.